Hello everyone, my name is Ngeh and I'm joined by my other teammates Jiali, Zhang and Feng. The topic for our paper is designing a smart helmet for wildland firefighters to avoid dehydration by monitoring biosignals. As we all know, firefighters face incredibly harsh conditions while performing highly demanding physical work. What we often don't see is what happens when they go over their limits, when they break due to overexertion. Dizziness, hard time talking, throwing up, and even collapsing. In fact, if we look back past the 20 years, over 300 firefighters have passed away in this combat. The most shocking stats might even be the fact that over 60% of those fatalities are caused by overexertion, and that every other firefighter out there has, at some point, seen someone collapsing on the field. Today, firefighters rely exclusively on observation to both report and try to anticipate these situations, and often it's just too late. We believe that the status quo has to change and that technology can help prevent these incidents, and that's the main premise of our work. Next, I'll talk about solution. Since we want to use technology to prevent incidents from happening to wildland firefighters, our solution is to use heart rate, temperature, and movement data to alert them and their supervisors before incidents happen. There are two components to our solution, the smart helmet and the mobile app. The helmet works independently to collect data and will alert the firefighter when abnormal health data is detected. The app enables the user to view their health data and also transmit it to the supervisors. If there's a potential risk to a firefighter, the supervisor will be alerted with a notification. Next, Jiali will talk about the prototype of the helmet.
Thanks, DJ. In order to get heart rate, temperature, and movement data, we use the heart rate sensor, infrared temperature sensor, and an accelerometer. The raw data from the sensors are then processed on the featherboard using our algorithm. If an abnormal health data is detected, we would nudge and alert the user using our array of actuators, which includes the nail pixel light, vibration motor, and a buzzer. And all these are powered by 3 AAA batteries, as they are also currently being used for headlamps. To complement our helmet-mounted device, we developed a mobile app using React Native to be used by both firefighters working on the line and their supervisors. The firefighter side focuses on collecting profile information, some enhancing the onboard algorithm like age, and establishing the connection with the helmet. Also, firefighters can provide feedbacks on how they are feeling during breaks, as seen on the right. On the other hand, a supervisor has an actual tab available. There, they can create a new crew and manage it, being able to visualize the crew members' health data and the eventual alerts in real time. In order to get the stable data for analysis in our algorithm, we collect the heart rate on the temple, temperature on the forehead, and accelerometer data on the top of the head. Based on this biosignal and corresponding ranges for different physiological status, we can clearly understand the underlying problem when our firefighters is working on the field. These problems or events can be divided into 4 categories based on their severity, which are emergency situations, drinking water, falling down, and helmets off. Next, he will talk about our functional tests and the future work.
Thank you, Jiali. So at the end of the project, we run a full-term functional evaluation to prove that our product works as we planned. We initially test the Fireworks app and other system, which are the core section of our project. Then we did further testing to see whether our helmet has a reliable data pipeline and whether it can run over a long time. The testing result is convincing. All the implemented functions in the apps works properly, and the supervisor notification and location information at the end of this slide are 2 functions that we plan to implement in the next generation of the helmet. Of the 9 events, the algorithm can be triggered successfully, but we can see clear notification for each event as we discussed in the previous section. From the charts on the top, we can see that our data pipeline is reliable to transmit data during works. We can also see from the bottom chart that the temperature data is very stable except for a half-second data loss during the long durations testing. And our heart rate data is stable all the time. Finally, to talk about the possible future work, we're trying to figure out a peer-to-peer communication channel which can be used in the absence of cellular networks. We're also prepared to implement the location features such that crews can keep track of their members. Most important point is, we're trying to upgrade our product into an attachable standalone device such that our product can realize mass production earlier and also fit on more types of helmet. That's all we have in this presentation. Thanks for your time. We are open for questions.